All right, today is Friday, April 15. We are going to cover something called the quadratic formula. Notice this is day 1 of the quadratic formula. Next class is day 2 for the quadratic formula. Also notice that because that our next class is not until April 20. You guys have been working hard. I'm giving you Monday off. Your other teachers are also giving you Monday off. It's Patriots Day. Okay? Best thing about living in Massachusetts. All right, any questions on the calendar? Okay, then here we are on page 190. There's a lot of stuff going on in this class. We're going to try to move as quickly as we can. In this lesson, we learn how to use the quadratic formula to solve quadratic equations. Number 1, graph A, which is pictured there, represents the parabola for this quadratic equation, y equals x squared plus 5x minus 6. Looking at the picture, we can approximate the two x-intercepts. It's hard for me to tell where they are. Is it here? Here and here, I think. Yeah. So we're buying -6 and 1 for the two x-intercepts. Okay, so it's easy if the picture is given to you. We can use the graph to identify solutions to this equation, 0 equals x squared plus 5x minus 6, which is exactly the same as this equation, except for what change? The y is now 0, and places where the y is 0 are exactly the two dots that we've plotted, right? Those are the places where the y is 0. And so solutions to that equation are x equals what numbers? -6 and 1. So we're making a connection here. It's actually a connection we also made on the first class of the semester, but that if you want to solve an equation, you can think about finding particular points on a graph. And we did this on the first day. So suppose we didn't have the graph given to us, but we still wanted to solve that same equation. I'll circle it again. How would we solve that equation without the picture? 2x2 box. Ultimately, we want to factor the thing. So we're not going to spend our time doing it here, but you guys are all experts at the box. So I will just write the answer. It's an x plus 6, x minus 1. Go ahead and copy that. And then we're in good habits here, and we're not just writing the solutions, but we're writing two equations. X plus 6 equals what? 0, or what's the other equation? X minus 1 equals 0, right? Splitting it into the two pieces. And we get x is -6, and we get x is 1. And those are the two solutions to the equation. Lo and behold, they match exactly what we read from the graph, okay? So that's all well and good when the thing factors. If you want to solve that 0 equals equation and the thing factors, super. We have a way to do it. But let's come down here to graph C, which is a different equation, y equals x squared plus 2x minus 5. Looking at the picture, the intercepts appear to be roughly -3.4 and 1.4, something like that. And if I wanted to find them exactly without referencing a picture, we would want to solve this equation here, right? And we would try to factor that equation. And you would do the 2x2 box. And we're just going to kind of zip to the punchline here. When you do the 2x2 box, you'd be looking for two things whose sum is what? 2x, right? The middle guy. And whose product, you can imagine the 2x2 box with an x squared in the top left and a -5 in the bottom right. And the product is -5x squared. So -5x squared is pretty friendly. There's not many things that multiply to -5x squared. What are the only two possibilities? 5x and -1x, or -5x and +1x. That's it, right? And when we add them, in either case, can we build the sum of 2x? The answer is no. So if this had been a problem where it just said factor this, what would your answer be? Cannot be factored, right? Can't do anything to it. But still, there are solutions to that equation. we know that they're roughly negative 3.4 and 1.4. It's just that factoring is not the tool that's going to get it for us. So we need a new tool, and the new tool is this thing called the quadratic formula. So here it is. If you have a quadratic equation written in this form, ax squared plus bx plus c equals 0, don't forget, still need to have that 0 there, then the solutions of that quadratic equation are given by this beautiful formula right here, which you have, I think, I'll raise your hand if you've seen it before. Raise your hand if you at one point in your life had it memorized. Raise your hand if you still have it memorized. Yeah. Okay, so we're going to use that formula. You don't need to worry about memorizing it. I will provide it on any quiz or test where I want you to use it, but I need you to be able to use it. If you are into memorizing things like that, you can YouTube Quadratic Formula and Pop Goes the Weasel, and you'll find people singing the tune to Pop Goes the Weasel, but using that formula. So that might make it memorable for you. Let's see if we can use the formula. So here's our equation, same equation that we just failed to factor on the previous page. First step, if necessary, put the equation in standard form. Notice we need one side equal to 0, which we have. It's already in standard form. Second step, identify and write down the values for a, b, and c. A is always the number touching x squared. What is the number touching x squared in this example? It's an invisible 1. B is always the number touching x. What is it in this example? 2. And I'm going to circle the plus sign there. You don't need to write positive 2, but I'm just going to circle it. Whatever sign is there is copied. And then finally, C is the number that is sitting by itself, not touching any x's. What is it? It's not 5, it is negative 5. Really important to grab the sign. And then step 3 is to substitute those values of a, b, and c into the quadratic formula and then simplify. So let's see if we can just kind of follow the steps here. This is already written out, so we're just going to do some pointing. So here we go. First thing I see is negative b, which is the opposite of b. What is the, off the screen here, what's the opposite of b? Is negative 2, so that's there. Plus or minus square root of b squared. So what number is getting squared? 2. 2 squared. Minus 4 times a times c. That's 4 times 1 times negative 5. Yeah? All divided by 2a, all divided by 2 times 1. Notice that every single number that we substituted in for a, b, and c is inside of what? Parentheses. You don't always need to put parentheses around all the numbers, but sometimes you do. And so better to use too many parentheses than not enough, right? So my recommendation is every number is getting put in parentheses as a rule. Okay, and then the rest of this is going to be simplifying. So 2 squared, that's easy, that's 4. Negative 4 times 1 times negative 5. So people will say 20 for that, but sometimes we'll get the sign wrong. And for me, I just look at how many negatives I have. How many do we have? We have 2. So altogether, when you have 2 negatives, what is that? That's a positive. And so for me, I don't even pay attention to the negatives. I just do 4 times 1 times 5. That's 20. And then I decide whether it's a positive or a negative just by counting symbols. Okay, 4 plus 20 is 24. So far, so good. 24, we need to rewrite in a certain way. How are we going to rewrite 24 given that it's in a square root? Six times 4 is the winner. 24 is also 8 times 3, but that's not useful to us. So we remember how to simplify square roots is we needed to factor 24 into a perfect square like 4 times whatever else. 8 times 3 is not good. Neither of them is a perfect square. And then we know we've got this wonderful property of radicals that says you can split it up when you have multiplication. And the square root of 4 comes outside as a 2, and the square root of 6 is still inside. And so the square root of 24 becomes 2 square root of 6. Okay, and then remember, way back we did this kind of like isolated type of problem that looked like this. I just started you on something that looked like, actually I think I started you on something that looked like this guy. And we split it up into two fractions, right? Negative 2 over 2, and then 2 root 6 over 2 with the plus or minus in between. So we did that kind of simplifying a few classes ago so that we could finish these problems without too much difficulty. So we just split into two fractions and we reduce the fractions separately. So negative 2 over 2 becomes negative 1. 2 root 6 over 2, the 2's are both outside so they can cancel. We just get root 6. So negative 1 plus or minus root 6. These are the exact solutions. Now the fact is, solving this equation that's off the screen here was supposed to give us the x-intercepts from that graph, which we approximated as negative 3.4 and 1.4. So what I'm telling you is that if we type these into the calculator, we're supposed to get the 1.4 and the negative 3.4, but we'll get a lot more digits than that. Okay, so this is not like this is very much tied into that graph. It looks quite unrelated, negative 1 plus or minus root 6. Who can visualize that? Well, I can't, but I can think of the decimals. So let's see if we can get our exact, our decimal approximations. So go ahead and take a calculator out. If the only calculator you have is your cell phone, then borrow one of mine so you're prepared to type these complicated things in on the test. Don't bother practicing with a cell phone or a graphing calculator. Need one? Who else needs? There we go. Good, here we go. Emma? There you go. All right. So what we're going to do is type in these two things here, the negative 1 plus root 6 and the negative 1 minus root 6. But the fact is, oftentimes it won't simplify as much as this one did. So what I'd rather we get practice with is typing in the more complicated thing where it might not simplify. So this is what we are going to carefully type into the calculator. Two options. For me personally, I prefer to do it in two steps. I do the entire numerator, negative 2 plus the square root of 24. That is right there, and I type it in just like that. So type that in, hit enter. Make sure you get what's on the screenshot there, 2.89 and change. And then once you've done that, just hit the division sign and then the 2. We should get 1.449 and change. Raise your hand if we're getting stuck. That looks good. Go back here. Oliver, you got it? You used a little subtraction symbol here. Sorry, you used an, I'm not sure what you typed in actually. What did you type in? So it should be a negative 2. Oh, it's just this first symbol shouldn't be here. That 2, just hit the delete key. It's in the top somewhere. Yes. It is not close enough. The other option is to do it all in one shot. And you can do it all in one shot, but the standard thing, if you do it all in one shot, is wrong. This is the standard thing to type in. Negative 2 plus the square root of 24 divided by 2. After all, that's exactly how I would read it, right? Negative 2 plus the square root of 24 divided by 2. But what does the calculator think you mean? Is the 24 divided by the 2, and that is not what we mean. We mean the whole thing divided by 2. So if you insist on doing it in one shot, it's at your own risk, because you need to remember to put extra parentheses that aren't in the problem when it's written. And so I've done that here, and you'll get the answer, but you got to make sure you remember the parentheses. For me, it's easier just to do the numerator by itself. It's complicated enough. Hit enter and divide it by 2, then enter. If you've got the 1.449, go ahead and do the other version. We did negative 2 plus square root of 24 over 2, but there was a plus or minus. So go ahead and do the other guy, negative 2 minus the square root of 24 over 2. The answer is about negative 3.449. Did we get there on this one? Yeah. Yeah, that's it. Divided by 2. Yeah, that does it. As long as you get there, however you get there is good. All right, so negative 3.449. We got the second one. Yep. Got them both. Super. You're doing crazy things here, Evan. Try just start again. Emma, how are we doing up here? Square root is it's above the x squared button. You have to hit the blue first. There you go. And hit the 24, then equals, and then divide by 2. And we should get 1.449. No. Negative 2. Oh, you didn't. This was a 24. Then divide by 2. Okay, any questions on typing this stuff in?
My calculator is remembering every answer.
So yeah, if you hit the up arrow, it's good. All right, so what did you do wrong? Okay, so every time you hit this button here, you're saying negative, but that's the subtraction key, which looks an awful lot like the negative sign. Yeah. Okay, let's go to the next page. We got one more big example to try. Here we go. So just to be clear, on a test or request, I expect that I will ask you to solve a quadratic equation using this brand new quadratic formula, and I expect that you will be able to provide me with the exact answers. That's the one with the radical still in it. I expect that you can simplify that radical 24 boiled down to a radical 6 after we reduced, still exact. And I expect you to give me decimal approximations. I'll be clear, nearest hundredth or nearest tenth or something like that. So this is the most complicated thing I'm asking you to type into the calculator, but it's a skill that you need to develop as you're doing the homework and stuff. Okay. All right. So next example is here. We're going to solve this crazy equation. Negative 2x squared minus 7/3 x equals negative 1. So maybe what we're not so thrilled with in that equation is what? Fractions. So let's get rid of the fractions right off the bat. The way we're going to do that is to multiply by the lowest common denominator. There's only one denominator there. It's a 3. So we're going to multiply both sides by 3. And when we mean both sides, we really mean both sides, everything in both sides. And so this 3 on the left-hand side distributes. So what do you get when you distribute into the first term? Negative 6x squared. When you put that 3 on the second term, some people will be tempted to put a 21. Don't. You put the 3 there specifically so that what happens? You get rid of it. So the 3 on the second term just plain cancels and you just get negative 7x. Really common mistake. I see this all the time. This is the distributing into the second term, right? And all the time I see people do this. 3 times negative 7, that's a negative 21. 3 times 3, that's a 9. What's the problem? Am I? I'm not changing it at all. If you reduce this 21 over 9, divide them both by 3, what do you get? Negative 7/3. This would be really surprising if I could take a number, multiply it by 3, and get right back to that same number. That's a problem. And the reason we introduced that problem is that we didn't actually multiply by 3. What did we multiply by? We should have multiplied by 3 over 1. What did we multiply by? 3 over 3. You put a 3 on top and bottom, you're doing nothing because you're multiplying by 3 over 3, which is just 1. So when you multiply by plain 3, if you need to, put that placeholder down there to prevent you from putting a 3 downstairs. It doesn't belong downstairs. That 3 is exclusively upstairs. But perhaps better than all of that is to just say, hey, the 3 cancels. Don't do any multiplying. Okay, so we're going to get rid of this. I don't want any traces of that. Okay, and then on the right-hand side, 3 times negative 1 is just negative 3. So here, I multiplied everything by positive 3. I did positive 3. Okay, so I am ready to read off the A and the B and the C. How much is A? -6. Somebody else, how much is B? -7. Somebody else, how much is C? -3. Fantastic. We're going to get this problem wrong if we do this. What mistake did we make? C. C sure looks like -3, Liam. What's the problem? It's on the wrong side. First step before you use the quadratic formula, before you identify A, B, and C, is to get what number on one side? 0. It's so important to get that 0. So we're not ready to read those off until we move the 3 over. It becomes what? +3, which is written here. So how much is the C? C is +3, right? And the fact that so many people bought into C being -3 shows you how common that mistake is. So easy to make that mistake. So make sure you have a 0 before you grab A, B, and C. Okay, let's give this a shot. -B, plus or minus, all this stuff. Okay, so I'm going to encourage parentheses around everything. So I'm going to write the shell of the quadratic formula with parentheses where every letter is. So if you write that shell, it's just a matter of putting the correct numbers into each parentheses. Okay, first parentheses, -7, right? It's going to change to a +7, but you've already got the negative in front of the parentheses as part of the shell of the quadratic formula. Okay, what number is getting squared in the next parentheses? -7. Next parentheses, -6. Next one, 3. Last one, -6. Okay, so we just carefully plug in to all the parentheses. Now we're doing some arithmetic, but it's, again, very careful arithmetic. I don't think it's time to grab the calculator, not yet. -7 is 7, plus or minus, square root of -7 squared. Is that -49 or +49? It's +49. +49 is correct. However, if we had not been so diligent as to put parentheses and we just did -7 squared, writing it that way, is that +49 or -49? That is -49, which is not the right answer. Right? Without the parentheses, you get the wrong answer because we are supposed to square -7. And if you don't square -7, but just square 7 and then plop a negative in the front, you get -49, which is wrong. Okay. All right. Next thing I'm going to do, I'm going to forget all the negatives inside of here. I'm just doing the multiplication of +4 times +6 times +3. Let's see, 4 times 6 is 24, times 3 is 72. So I'm putting a 72 there. And then after that, I'll do the sign. Is it a positive or a negative? Positive, because there are 2 negatives. Downstairs, 2 times -6, -12. Okay, let's keep trucking here. Equals 7 plus or minus square root of. Then we do that arithmetic again. We could do without the calculator. What is it? That's a 121, right? Over -12. That's good. Oftentimes you can go no farther when you get to a square root like this. But the square root of 121 happens to be an integer. What is it? 11. So I put one in here where it happens to be an integer just so that we know how to handle it when it's an integer. So we have that. Typically, at this stage, we would split this up into 2 fractions. I'm going to write something that I don't want you to copy because that's not what we're going to do here. Typically you would do this. That's not right. Typically you would do this. 7 over negative 12 plus or minus what fraction? 11 over negative 12. Don't write that. Typically this is what we would do. Typically the square root is still in the problem, and this is exactly what we should do if there's still square roots. But in the rare case like this one, where we happen to have a perfect square in there, what we do is we split it, but in a different way. 7 plus 11 over negative 12, 7 minus 11 over negative 12. It's literally what the plus or minus means, right? It's just a shorthand way of saying those two things. Yes, we are writing this down. And now we just have two separate simple calculations to do. And the first one, upstairs is 18, downstairs is negative 12, which reduces to negative 3/2. And in the second one, upstairs is negative 4, downstairs negative 12, reduces to positive 1/3. Questions on that? Yeah, only because we had a perfect square. But almost every other problem is going to still have a square root in there, and then there's no reason to split. Other questions? Okay, activity starts on the next page. I will walk around.